Alright, you are welcome once again. I am here to introduce another type of integration, how to integrate logarithm functions. Logarithmic functions, as in we are integrating log functions this time around. Okay, now integrating log functions is very easy. Just the rule is that when we have if we have to integrate a function where the numerator is a derivative of the denominator, that we are integrating this form, we're going to have log of the denominator to base e plus c. So we are finding, so what is the meaning of that? It means when we have a function where the numerator is the derivative of the, where the numerator is the derivative of the denominator, then the integral of that function is going to be natural log of the denominator plus c. So finding the natural log of the denominator, then add c to it. Log base e is actually Napier or natural logarithm, and you can short it as len. It can be len u of x plus c. So that is how it is obtained. This is the law. So for instance, if we are to integrate 1 over x, for instance, dx, now you can see that when we differentiate the denominator, which is x, to find if x is our x, now the denominator, now if y is equal to x, that's the denominator, and we obtain the y dx, or denominator is going to be 1. So you can see that the numerator is 1, the denominator is x, so the numerator is the derivative of the denominator. So in that case, the integral of this integrand is going to be log of the natural log of the denominator and plus the constant of integration. How do you understand that? You just relate the numerator and the denominator and see how are they connected in terms of differentiation. That is just it. So that's differentiation in integration. Differentiation in integration. Right. Let me give you like 1 or 2 examples to buttress that. Now, evaluate 2x over x squared plus 4 dx. It is obvious here that the denominator is what? Let's say the denominator is y is equal to x squared plus 4. Alright? When you differentiate the denominator, the y dx is going to be what? 2x. This one is going to be 0. Okay, so we have 2x. So it is obvious now that the numerator is 2x and the denominator is x squared plus 4. So you can see the connection between the numerator function and the denominator function. The numerator is the derivative of the denominator. 2x is the derivative of x squared plus 4. So hence, we conclude by the law that the integral of this is going to be natural log of x squared plus 4. Then we add our constant of integration. Or we can still write it as len x squared plus 4, okay, plus constant of integration. I hope you understand that a little. That is how to differentiate log functions. Okay, let's take another example that you may also like. When we have to integrate 4x all over 8x rather, 8x over 4x squared plus 4 dx. Now look at the denominator. Denominator we have 4x squared plus 4. Right? When you differentiate that, you're going to have 8x plus 0, which is 8x. So you can see directly that the denominator, when differentiated, gives us the numerator. So the law can be easily applied. So the integral of that function now will be what? Will be equal to the natural log of the denominator right? Then plus constant of integration. And you can as well write it as ln 4x squared plus 4, then add the constant of integration to that. I hope you are getting it. Right? I love to give multiple examples so that you have good understanding as touching this. Now, the penultimate example I'm going to give this time around is to integrate when you are to integrate 3x, right, all over. Now, please, are we together? 3x here, 3x, should I make it that way? 3x squared all over x cubed plus 2 dx. Now you see that? Now, let's pick out the denominator to examine the relationship between numerator and denominator. You can see that the denominator is x cubed plus 2, right? When you differentiate the denominator, you're going to have 3x squared plus 0. Okay? So you can easily see that the numerator of the fraction here is the derivative. When you differentiate the denominator, we have the numerator. So when this happens, then we apply the law of log function derivative, integration. So we have this to be equal to natural log of the denominator plus 2, then plus constant of integration. Or we have ln x cubed plus 2, then plus c. So that satisfies the law that I've introduced earlier. But before we go, I want to bring in a similarly complex question. Now evaluate integral 4x all over 4x plus 2 dx. Now looking at this one, we have to carry out a process, because when you differentiate 4x, we are going to have when you differentiate 4x, that's 4x squared here, when you differentiate 4x squared, we are going to have 8x, so and not 4x. So what are we going to do here? It's a very simple thing. We have to introduce 1 over 2. That to be, this thing is the same thing as 1 over 2 integral 8x over 4x squared plus 2 dx. So now you may ask me, why half here and why 8x here? That is mathematical induction. You know that when these two can only divide the numerator. So when these two divide this 8, we have 4. So we still have what? 4x. That is to help us to carry out our integration. And when you have this, then our answer is going to be half. Okay, when we integrate this one, it's going to be what? Natural log of the numerator plus 2, right? Plus 2, then plus what? Plus c. So that is what? Half log. That's natural log of 4x squared plus 2, then plus what? Plus c. Always remember to add the constants. Just check out what we did. We introduced this half because when we differentiate 4x squared, we have 8x, and this is 4x. So we have to introduce a factor that will reduce this 8x back to what? To 4x. That is what we did, and that is how to do it. Thank you very much, and I wish you all the best. Remember to visit my blog for clarity. Remember to download materials on my blog. Once again, my blog is www.examso.blogspot.com. I wish you all the best. Bye for now.